A transistor is a semiconductor device that can rectify, amplify, and switch electronic signals. It is used to switch signals on and off. This is used in digital circuits, such as computer processors and memory chips. A transistor can also be used to amplify weak signals, such as those from a microphone or TV antenna. This is essential for many electronic devices, such as amplifiers and radios. There are two main types of transistors: bipolar junction transistors and field effect transistors. We will explore how a bipolar transistor works as a switch and amplifier. A bipolar transistor has three layers of semiconductor material: the emitter, the base, and the collector. The emitter and collector are heavily doped, while the base is lightly doped. This creates two p-n junctions, one between the emitter and base and the other between the base and collector. Electrons are in high concentration in the emitter and collector regions, therefore, they migrate to the base region. Similarly, holes migrate from base to the emitter and collector region. This migration of charges creates a charge-free zone, called depletion region. This region acts as an insulator or a variable resistor. If the base emitter junction is forward biased, the depletion layer is narrowed and more electrons can flow from the emitter to the collector. This increases the collector current and the transistor acts as an on switch. If the base emitter junction is reverse biased, the depletion layer is widened and no current flows from the emitter to the collector. In this way, a transistor acts as an off switch. Imagine a transistor as a valve in a water pipe. When the valve is fully closed, no water flows. When the valve is fully open, water flows unrestricted. The valve can control the flow of water through the pipe. By adjusting the knob, you can control how much water flows through the pipe. Similarly, the base current controls the collector current in a transistor. Just as the small movement of the valve knob can control a much larger flow of water, the small base current controls a larger collector current. Changes in the base current result in proportional changes in the collector current, leading to signal amplification. The common emitter configuration is commonly used for amplification. Here, the base emitter junction is forward biased, and the collector base junction is reverse biased. Small input signal is applied to the base emitter junction. This signal varies the voltage across the base emitter junction, causing changes in the width of the depletion region. As a result, the base current changes. These changes in the base current cause proportional shifts in the collector current, leading to signal amplification. The amplified output signal appears across the collector-emitter junction. This output signal is essentially a larger and amplified version of the input signal. By controlling the base current, we can control the collector current, and thus, amplify the input signal. To extract the amplified signal, a load resistance is connected in series with the collector terminal. The varying collector current, modulated by the input signal, results in a varying voltage drop across this load resistor. This voltage is the amplified output signal. We hope this video has provided valuable insights into the intricate world of transistors and how they work. Thank you for watching.